Okay folks, this is a little video I think I've been doing there for quite a long time and just never got around to doing it. About a year ago, roughly, I'll say about a year ago, came across a bunch of old tubes and vacuum tubes. They're little small peanut tubes, but these fellers, as far as I know, are back from 40s, 50s. And some of them, maybe one or two of them, could be rare. I'm not 100% sure. But we're going to figure out together the tubes that are here. We're going to research them on the phone here. And we're going to get some background on a couple of them. Just a couple of random ones. I'm not going to bore you too much on all of them, but we'll take a couple of random ones and we'll see what they are, what their history are, what the history is. And yeah, so if you're interested in that, stay tuned. Okay folks, so that's the tubes and two little accessories that I got with them. Got this little gadget here when you're wiring tube sockets, such as the octal type. Say if your jet socket there, plug your tube in, the socket this thing actually goes into. You plug this thing in the same as you would a tube. And this would open up the pins so you can properly solder up your components. And that's what, as far as I've read online, that's what this particular item is for. And then I just found this in that same bag. Not exactly sure what this is yet, so I'm assuming it's for wiring. Looks like it's SPG2 GPOW57. And on the other side, 5293A. I'm assuming it's for wiring. Chances are. So, this is the tubes that we have. So, we got a bunch of mallard tubes, as you can see. A lot of these here were made in Great Britain. So just for instance, that tube right there. Let's see. I'm going to type this in. And 55A2. I'm going to click this, and we'll see what kind of a tube this was. So there's the base diagram, cathode. That's the circuit that it would be built into. But the wording here, preferred operating voltage 6 milliamp, usable from 1 to 10 milliamp, 450 ohms, typical drift and voltage over 100 hours, plus or minus 0.1%. Identical to 85A2. There's a bunch of different tubes that it's identical to. There's a little photo of it. And then we can go back. National Valve Museum. It actually tells you a little bit more about that particular tube. The Mullard 85A2 is a small, special quality voltage stabilizer. The striking voltage is 115 volts and maintaining voltage is 85 volts. For a tube current variation of 1 milliamp to 10 milliamp, the voltage regulator is 4 volts. The valve would have been used to directly stabilize the voltage for an oscillator, or be employed as a voltage reference for a stabilized supply. In the later case, the tube would be operated at a constant current. In early 1955, Mullard brought out two special quality versions of the stabilizer. The new designs were designed to operate in the presence of vibration, while maintaining a long life, and were aimed at industrial and military applications. Type M8098 fitted with a B7G base, and Type M8142 with flying leads for direct soldering into the circuit. And it goes a little bit more information. The interesting thing about this exhibit is the identification label. So as you see, some of these even had a little sticker that was on them. So yeah, that would be this tube right here. 85A2, made in Great Britain, Mullard. CV449. So there you go. That's just one tube out of a whole batch. So what we'll do tonight, I'm just going to go through, say, 5 of these tubes. And I guess over the next little while we'll go through this whole pile of tubes, I guess, and see what we got here. But that is tube number 1, the 85A2 Mullard, made in Great Britain. So you've got another one here. This is a Mullard M8083. CV4016 looks like. Also made in Great Britain. So I'll do a little bit of reading on it. Basically, the M8083 is a special quality version of the EF91. The M8083 was a more rugged build than the EF91 and was designed for applications where vibration during operation was unavoidable and where the performance could be predicted when subjected to such vibration. The obvious application is mobile communications, especially military. The reverse of the envelope carries a CV designation, thus demonstrating equivalence between the two designations. The blue band obscures the internet structure, but the anode in this version is a solid sheet folded to shape. The EF91 uses 2 small plates held together with metal bands. The thin glass tube envelope is 18 millimeters in diameter, and excluding the B7G base pins is 49 millimeters tall. And the reference data sheet 1040 type M83 was first produced in 1953. 1953 that the M8083 was produced by Mullard. Interesting little tube. And then we have a Mullard CV4014. The CV4014 is a UK service designation for the civilian M8083 or 6064. This in turn is a special quality version of the EF91 CV138. The M8083 has a more rugged build than the EF91 and was designed for operation areas of vibration, especially aircraft. The thin glass tube envelope is 18 millimeters in diameter, and excluding the B7G base pins is 47 millimeters tall. Data sheet and 1040 type CV4014 was first introduced in 1953. So there we have it. It's a downgraded version of the 8083. Interesting, huh? Almost looks identical, but this one has a lower grade than these two. Cool. And then we have a Westinghouse CV3998. The CV3998 is a high-slope RF beam tetrode primarily intended for use in wideband amplifiers in telephone carrier systems, radar equipment, and measuring equipment. The CV specification shows that the government requirement was for the GPO telephone system. The prototypes were the 5A/170K from STC and E180F from Mullard. The very small size helps to reduce the interelectrocapacitance and thereby raises the maximum usable frequency that the device can operate at. The thin glass tube envelope is 21 millimeters in diameter, and excluding the B9A base pins is 33 millimeters tall. References, datasheet, and 1040. That is the Westinghouse CV3998. Interesting little tube, and it's pretty small. And then this will be the last tube, I guess, for tonight. That would be the 6688. And this particular model was built or made in the United States. And this is what it says online. It says the 6688 is a special quality UHF high slope RF pentobe, primarily intended for use in wideband amplifiers and telephone carrier systems, radar equipment, and measuring equipment. The type is etched into the glass as well as being printed. GE logo covers the end in etched letter of USA. The pentobe is a small part of the miniature envelope. The thin glass envelope is 21 millimeters in diameter, and excluding the B98 base pins is 37 millimeters tall. So special quality UHF high slope RF pentobe. Nice little tube. Here folks, like I said, I just gone through a few tubes here tonight. I just figured maybe you might be interested in seeing them. I got like I said, a few over here behind me here on the side. But you know, if you're interested in seeing a few more of the tubes I got here, I got a lot more besides what I'm showing here. They're in the other room, so if you're interested in seeing them, in the comments below. You want to see more? Let me know. I'll next few nights put up some videos on the tubes, bit of information on each one of them. I know there's a few tube fanatics out there. I do like collecting them for the most part. I don't build a whole lot of circuits with them. Mainly, well, high voltage transformers is a big issue, as we know, trying to get for tubes, and high voltage circuits, which you have to be very extremely careful with. Quite the shock hazard involved with those. But yeah, so I got these little peanut tubes, as they call them, right here, and I've got a few big whoppers in the other room in there that we'll show you later. Anyways, hope you enjoyed the video, folks, and if you want to see more on these vacuum tubes I got here, give me a thumbs up and comment below. And of course, if you haven't, make sure you subscribe to the channel over there, here, there, wherever it is, subscribe button. Make sure you hit that button, and of course you got the little bell signal, little bell icon next to the subscribe button. Make sure you click that, and you'll know when I have each individual video uploaded. You'll see them. Alright folks, all the best, take care, and we shall talk to you in the next video, whenever that shall be. It'll be about tubes, some circuitry, a radio, who knows what. Anyways, got some suggestions for ideas for videos, post in the comments below. I'd love to hear from you. Anyway folks, 7-3, all the best, and take care. This is Reno 63, out.